Watch this video about confidence intervals for proportions. The first question states, in a study of perception, 80 men are tested and 7 are found to have red-green color blindness. We are asked to construct a 90% confidence interval estimate of the proportion of all men with this type of color blindness. First, we find E, which is called the margin of error. E is equal to our z-score times the square root of p hat times q hat divided by n. Since this is a 90% confidence interval, that means we have 10% left for the two tails. Since it is a normal distribution, it is symmetric, which means that 5% goes in each of the tails. 5% is in the left tail, 5% is in the right tail. If you look up the area 0.05 in the normal table, you get the z-score of 1.645. We also need to find p hat. P hat is the sample proportion. In this case, p hat equals 7 divided by 80, which is 0.0875. Q hat is 1 minus p hat. So q hat equals 1 minus 0.0875. Q hat equals 0.9125. We now have every value that we need to find E. So E equals 1.645 times the square root of 0.0875 times 0.9125 divided by 80. E equals 0.0520. Be very careful putting this in the calculator. Make sure that you can enter the formula correctly to get the correct answer. We are now ready to construct the confidence interval. The formula for the confidence interval is p hat minus E is less than p hat plus E. P hat is 0.0875 minus E 0.0520 is less than P is less than 0.0875 plus 0.0520 equals 0.0355 is less than P is less than 0.1395. The next question states women have a 0.25% rate of red-green color blindness. Based on the result from Part A, can we safely conclude that women have a lower rate of red-green color blindness than men? Our probability was 0.0025, which is less than 0.0355. Because of this, women have a lower rate of red-green color blindness than men. The next question states, each year billions of dollars are spent at theme parks owned by Disney, Universal Studios, SeaWorld, Busch Gardens, and others. A survey of 1,230 people who took trips revealed that 111 of them included a visit to a theme park. Find the point estimate of the percentage of people who visit a theme park when they take a trip. The point estimate is p hat. P hat equals successes over outcomes. P hat equals 111 divided by 1,233, so p hat equals 0.09. Next, we're asked to find a 95% confidence interval estimate of the percentage of people who visit a theme park when they take a trip. We must first find E, the margin of error. Since it's a 95% confidence interval, that leaves 5% for both ends of the graph. Since the graph is symmetric, we split the 5% in half, which gives us 2.5%. So 2.5% is in the left tail, 2.5% is in the right tail. If you look up an area of 0.025 in the normal table, you see that the z-score is 1.96. We've already found p hat. In part A, p hat was 0.09. Therefore, we can find q hat. Q hat is 1 minus 0.09. Q hat equals 0.91. We now have everything that we need to find E. E equals 1.96 times the square root of 0.09 times 0.91 divided by 1,233. E equals 0.0160. Now to build the confidence interval, p hat minus E less than P is less than p hat plus E. That equals 0.09 minus 0.0160 less than P less than 0.09 plus 0.0160. 0.0740 is less than P is less than 0.1060. The third question states research studies crashes of general aviation airplanes and found that pilots died in 5.2% of 8,411 crash landings. Construct a 95% confidence interval estimate of the percentage of pilot deaths in all general aviation crashes. First, we find E, the margin of error. E equals, since again this is a 95% confidence interval, we already know the z-score is 1.96. So 1.96 is the z-score. P hat was given the 5.2%, which converted to a decimal is 0.052. Q hat is 1 minus 0.052. Q hat equals 0.948. E equals 1.96 times the square root of 0.052 times 0.948 divided by 8,411. E equals 0.0047. Now we can construct the confidence interval p hat minus E is less than P is less than p hat plus E. 0.052 minus 0.0047 is less than P is less than 0.052 plus 0.0047. The confidence interval is 0.0473 is less than P. Part B is less than states, 0.05. Among crashes with an explosion or fire on the ground, the pilot fatality rate is estimated by the 95% confidence interval of 15.5% to 26.9%. Is this result substantially different from the result from Part A? What can you conclude about an explosion or fire as a risk factor? That interval is higher, therefore the death rate is higher if explosion or fire is a risk factor. Question number 4 states, the drug Ziac is used to treat hypertension. In a clinical test, 3.2% of 221 Ziac users experienced dizziness. Construct a 99% confidence interval estimate of the percentage of all Ziac users who experience dizziness. First, find E, the margin of error. E equals 2.575 times the square root. P hat is 0.032 times Q hat, which is 0.968, divided by 221. E equals 0.0305. Now construct your confidence interval. P hat minus E is less than P is less than P hat plus E. 0.032 minus 0.0305 is less than P is less than 0.032 plus 0.0305. The confidence interval is 0.0015 is less than P is less than 0.0625. Part B to the question states, in the same clinical test, people in a placebo group didn't take Ziac, but 1.8% of them reported dizziness. Based on the result from Part A, what can we conclude about dizziness as an adverse reaction to Ziacs? The 1.8% falls within the confidence interval that we found in Part A. Therefore, the drug does not cause dizziness.